Hello, welcome to Enots Engineering. I'm Alan. In today's video we'll be making this height adjustment gauge for setting your tool height instead of using a tailstock, and I found this very useful on my lathe. It's made up of 4 parts and quite easy to make. So let's go into the workshop and see how we make one. The temperature in the workshop today is 21 degrees. On this Boxford lathe, sometimes when you come to adjust your tool or change your tool, you need to check that it's on centre height. And if you're working with a job between centres, that means you've got to take the job out, turn the tool around, move the tool over till it lines up with the centre, adjust the tool, bring it back, put the job back in and carry on from there. On this machine I'm lucky that the top slide here is machined flat, so it's not a casting with a dome on, it's a flat surface. The tool post I'm using, I can slacken that off and turn the tool round so it's facing me, and also I can adjust the tool by just touching that slightly. I can adjust the tool up by turning the screw, so all I need is some way of knowing what height this is to the centre of the lathe. So the first thing I thought was to take the tool off. Now if I move the top slide across so that the tool holder T-slot is basically under the chuck, put a dowel in the chuck. I've clocked that up so I know it's not running out. I can then measure from the top of that face to the centre of the dowel, and that gives me this face to the centre line. What I'm doing here is coming under the dowel, up to the dowel, from the face of the tool slide to the dowel, 805. So if we halve the 0.375, which is 0.1875, and add it to the 0.805, the distance from the tool post surface to the centre line becomes 0.9925. I don't want to machine the parts I'm going to make to that size and find out it's a fraction under. I would rather machine them a bit bigger and take a little more off if I need to. But I think at an inch, the tool was set at an inch, just above centre. I can always adjust it once I know the exact relationship when actually cutting steel. So what I need now is a way of getting that size 0.9925 from there to the top of that tool. So what I need is some way of knowing where that tip is to the face of this table. So if I could make something that holds that dial indicator, it tells me the movement up and down, then I can adjust this tool without having to go back to the centre. I've cut a piece off the end. This end's all malformed, as you can see. It's oval there. It's the end of the bar. I'm thinking I might be able to get an inch off this, just about. We'll try it. If it's scrap, I haven't lost anything. Okay, let's clean the face up. I've turned that, roughed it out. You can see there's still a part there that's not been cleaned up. But before I move it, what I want to do is centre drill the end just to give me a centre position. Now because I'm trying to get two parallel faces, I'm going to turn this between centres for the final cut. Okay, I'll leave the step between the two because when it's between centres I'm going to go straight the way across. So it's hot. You can see I've got an inch, well over an inch, inch and a quarter. That face is cleaned up. The other face is cleaned up. Just this edge here that's not cleaned up. So the next job is to put this between centres, machine the face and the diameter, and then machine the back face, so that I know the two faces are parallel and the diameter is true to the centre. Okay, well, just show you the setup I've got now. I've got my driving plate on the head here, the centre in this side, centre in this side, the works held between the two centres, and a driving dog on the part. This driving dog's not for truly a lathe. Normally a lathe one will have a bent arm coming out the back which fits into the slot on here, but because this centre I've got sticks out quite a long way, a normal driving dog wouldn't fit in there, so I've had to put a bolt through which drives the dog, which turns the workpiece. Okay, I've had to change to a little rotating centre because the centre I was using started to get too hot. So I've machined the outside and I've just machined the face. So what I need to do now is turn it round. Now the reason why I put it in centres in the first place is so I can get the size over the two faces. So what I'm looking for is around about an inch. So I've still got quite a bit to come off this. Right, I'll leave that at that. I've held it on the end that I just turned down. I've taken off the sharp edges. There's a reading. It's 1 inch. That's what I wanted. So the next job is to drill a hole through straight through the centre to accept a dial indicator. There's the outside face, which we finished off at 1 inch, and I've just put an undercut here to bring the rest of the face lower than that. Okay, all I'll do now is put a chamfer on the front of that hole. That end of the part's finished. I'll take that out, turn it round and just finish the other end off. So you've got a recess, flat surface, recess, bore. So what I want to do now is just put the recess Okay, so that's finished except for drilling and tapping. Taking a piece of brass, there's a little bit of brass I had in my scrap box. I'm going to drill an 8mm hole through it. What I'm making is a spacer to go between the face and the dial indicator. The idea is that the spacer fills in that gap, and I've looked through my box. I'm using a standard washer. I was going to make a piece that's screwed on the top, but I thought, well, if I use a standard washer I can always replace that quite easily, which goes on the top, which gives you basically the overhang to get your tool underneath. And then when this washer goes on the top of that, your DTI goes down and the washer will clamp between the DTI and the surface. I just want the width to be about 0.15, somewhere around there. 0.155, it's not that critical, it's only a little spacer. Before I've parted it off, I've actually taken the edge off this side and this side. It slides over the dial indicator and actually holds on the body of the dial indicator. This washer goes on with the flat side, because on this washer, these are standard fence washers for fence posts and things. One side's got a chamfer on the corner, the other side is flat. That goes on there. Then the flat side goes on there, and that leaves a small ledge all the way round. Just making the brass screw. To cut the thread, I just use the handle in the back of the headstock to turn the headstock. Wind it in. Once I get to the face, that will lock up. Reverse the handle. Take the clamp off the tailstock. Now I turn the die round so I can cut right up to the face and start it back in again. I'll change now to my chamfer tool. To put the knurling tool on, I'm just going to put a knurl on that thumb screw. The next job is to part that off. So that's it. I just put a piece of brass in the chuck with a 5mm hole in it. It's an M5 thread, so I can screw this onto the Okay, when you drill the hole in, this is an M5, drill and tap an M5, make sure you put it in the correct end. It's the end without the recess. It's the dial indicator end. And what I've done is I've just rubbed both faces on some wet and dry just to flatten off any lumps. There's the screw. So to assemble it, rub the bottom of the washer on some wet and dry. Don't forget there's a radius on one side, and the side with the sharp edge is the bottom. That just goes on the top. Originally I was going to drill and tap some holes to hold that on, but I don't think it's needed. I think what I'll do is use some, if I need to hold it down tight, I can put some super glue on there, just glue it on. At least then you can change the washer easy. The brass collar we made, which basically clears the dial on the clock. So that goes into there. Push all the items together to get them centralised, and then just nip up the screw and make sure that the indicator still moves. If you tighten that too tight, you'll crush the tube on the indicator and stop it moving. So that's it, finished. Let's see how it works. The main thing is not to tighten the brass screw too tight, otherwise you'll lock your dial indicator and stop it from moving. I've replaced the end with a normal dome ball end. So clean the top slide, put the dial indicator on, and just zero the dial indicator to the top slide. Release your tool holder, both the large clamping bolt and the adjusting one. Turn the tool holder round, so you just put your tip of your tool under your dial indicator, lock the clamping bolt, the tool holder, then just nip up, let's just undo this, then just nip up the tool holder so you can turn the adjustment, and as you turn it will lift the tool. When the tool touches the edge of the washer, the dial indicator starts moving, so it's just starting there, and just nip it up. That set the tool to tool height. So we can check that now with the slide. I'll release the, turn it over as if you're going to check it with the centre, and bring the centre in. And you can see from that the centre is in line with the top of the tool. Here's a quick sketch that you can freeze frame and copy. Well, that's it for now. Hope you've enjoyed it, and we'll see you next time on Enots Engineering.